Hey, how you doing?
Hello, guys, welcome back uh, to tutoring with me here. In today's session, we'll be talking about square root. How do we define a square root? Is if a is greater or equal to 0 and b is a real number. So b squared is equal to a is also called, in this case, b is a square root of a. That's being said, that a cannot be less than 0. It cannot be a negative number because we will talk later. Negative number does not have a real square root or real value. It has a imaginary value, imaginary roots. So we will just put that one right here. A has to be greater than 0, or in some cases even 0, and b is a real number. In that case, we call this expression, we can write it down as a b is a square root of a. So that will be here. So that will become like that. If we don't have a index number, the index number is always 2, which is a square 2. So that's how we deal with it. We'll talk about in this course we will particularly talk about the principal square root. We'll deal with positive numbers for now on. We'll do talk about negative square roots in the future sometime. I can't say when, but yes, we will cover them. Or maybe we will not need to cover them, but yes, we will be talking about square roots of positive numbers. For instance, 36. So what is that equivalent to? What is that? How do we solve that number? It's actually equal to. So we can write down this 36 in numbers of 6 times 6. Okay, we can write it down like 9 times 4, or you can just do dot or multiply. Okay, so with that expression, 6 times 6 is we learned that in the power sessions of the course that we have the same basis, and we can take one base and add the exponent will be 6 to the power 2, and we have a square root. So we already said here, if you don't have a power of the index, if you don't have an index number, the index is always 2, so this 2 will cancel out with that power. So that will be actually 6 to the power 2 over 2. These will cancel out, so our answer will be 6 here. So now let's see how this thing ends up. We can do we can just simplify that. So we can either, we can further simplify the we'll come to this. There's a property, we will discuss this, but before we do that, let's solve this one. We will divide this whole expression in two parts. So we'll do 3 times 3, one expression, time, we can write down that 4 as a 2 times 2, a different expression. I'll separate them in parentheses. Okay, so there will be 3 times 3 will be, we learned that from the power rule, will be 3 squared time 2 times 2. I'll do that multiplication mark here, will be 2 to the power 2, and that's still square root of 2. If you further simplify them, this root will cancel out with that, will remain 3 time this power will cancel with the square root, it will be leaving only on 2. So 3 times 2 will be 6. So no matter what route you take, your answer will be always the same. Okay. So no matter what route we take, we will end up with the same answer. We will discuss these rules and these properties later on in this very video. Before we go there, so we'll have to talk about this remembrance here. So like, remember, negative number don't have a real square roots or solution. However, it has a imaginary roots or solutions. Just to put some lights on these things, somebody said like, okay, how and why is that not working? So negative 4 has no real roots but imaginary. Okay, so that is just an idea right now we are saying, but how? Let's talk about this just in a little bit detail. Negative 4, let's say like we did talk about earlier, we got that opposite of a square. The roots are actually opposite of exponents. So let's say we have to find two numbers that can be multiplied and give me this number, because it's a complete imaginary square root. Because just discard negative 4 or negative right now, so we have 4. 4 is actually 2 times 2, so that means it has to be some sort of multiplication of 2 with a number or with a letter, which I'll discuss what that is. We cannot find any number, any sign like negative 2 times negative 2 will give me 4. 2 times 2 will give me 4, but it will not give me negative 4. So this will not work out. So that's why we said like it has no real value. But we said like we added an expression that, however, it has a what? What does it have? It has an imaginary value. So to prove that what our thoughts are, so negative 4 can be written down as a 4 times negative 1. Okay. So 4 can be, we can just we can split them back. 4 times, okay, that's 1 square square root of 4 times square root of negative 1. Okay, so square root of 4, we know what that is. It's 2 times 2, and square root of negative 1. 2 times 2, we can write down that as a 2 to the power 2, and square root times negative 1 square root. Okay, so we can write down this as a simply 2, and negative 1 under square root is equal to I, because I square is equal to negative 1. If you want to solve it for I, what we will do, we will put both sides under square root, will be negative 1 under square root. This will cancel out, so we will have I is equal to negative 1. So that value. So that's how we said, like, negative 4 is equal to 2I. And to prove that back, do a reverse proof on that. So 2I times 2I will equal to 2 times 2 is 4. I times I is I squared. Correct? So what is I squared? So it will be 4 times I is equal to negative 1 square. I'm sorry, negative 1 square root. So we will end up back, if you multiply that, will be negative 4 square root. So that was some extra thing that we have done here. Hopefully it doesn't confuse you. We'll move on to the something very important. So let's hang on, guys. 2I times 2I will become 4I squared. And what is I squared equal to? I squared is equal to negative 1. So that will become 4 negative 4. So negative 4 is our answer. But if you want to take a square root of that, it will become like under the square root. So that's how we get there. But let's move on to something to remember. I said a couple things to remember here. Square root of a plus b plus c is not equal to square root of a plus square root of b plus square root of c. In same manner, it's not equal to the subtraction of these same letters. Square root square root of a minus b minus c is not equal to square root of a minus square root of b minus square root of c. And how do we claim that thing? Let's put an example here. For instance, example will say like, let's add some number 4 plus 6 plus what is 10 plus 15 is not equal to, as we claim, square root of 4 plus square root of 6. We said that it's not equal, or it's against these things, and square root of 15. Let's prove that thing. So 4 and 6 is 10, 10, 20, 10 and 15 will be 25. Square root of 25 is not equal to 4 square root of 4 is 2, because it's 2 to the power 2, plus a square root of 6 is, we cannot simplify that, we just have to simply use the calculator to give us a rough value. With 2.45 plus square root of 15 is 3.87. Okay, now let's simplify this one. 25 square root of 25 is 5 to the power 2, and this will cancel out here. So step 2, that will be 2.45 will be 3.87. Now let's simplify this also. So 5, because square root of 25 is 5, is not equal to, so 2, let's add them. 2.245 plus 2 plus 3.87. Okay, it become 8 point some number, but I messed up. 2 plus 2.45 plus 3.87. Yeah, 8.32. Okay, that's 8.32. As we clearly see, 5 is not equal to this number, so that's how we have to be careful there. The total square root is not equal to the individual square root of those letters, so be careful. Something to remember. Okay, so now moving on to the properties of the square root. We have couple. That will be the multiplication and division. The square root of a times square root of b is differ here. In the addition, we can just not simply substitute them, or just can add them in under the same square root, because there are different values. But under the multiplication, square root of a times square root of b, since the degree of the roots are the same, we can put them under the same root and multiply them. Same root, because the degree, they use the same, they share the same degree, or the same index number, which is 2. So we can put them in under the same square root. That applies for the next level, which will be the cube root and other root, because if the index is the same, we can just put them under the same root degree or the index number. Now moving on to number 2 is square root of a divided by square root of b. So we can put them simply. We can also do that. A square root of a divided by b, we can just put them under one square root and be done with it. Okay, let's try to do some example and prove that thing. Prove these two properties here. Okay, so actually it's more than couple. Solve the following, if possible, simplify. Okay. Let's see. The one that I tick mark will do that. Keep bringing me the pencil. So they'll do that. I will solve this guy, this one, this one, this one, this one, and this one. So I'll leave you guys two. Let's do number 1 first. Number 1. Excuse me. So it says 2 square root of 2 times square root of 12. So we can use the same property, the one that we said. Since they share the same index number, we can put them under one square root. 12 times 2 or 2 times 12 will be 24. Square root of 24. All right, we could further simplify because it says like if possible simplify it. We can do 6 times 4. 6 times 4. So that will become 4 is 2 square times 6. Square root of 2 square times 6. So that will become, we can take that 2 out, and square root of 6. So, and if you want to take that back in there, you have to multiply by itself. Will be 4. 4 times 6 is 24. You can bring it back in and we'll make this number. But this just for simplification step. Okay, hope that wasn't that bad. Okay, so that is that, and you can, if you want to further simplify it, you just plug that number in the calculator and I'll give you the whole value of your square root. It will be 4.8. I'll do like approximate 4.898, and we'll keep going on. So that's why I'll stop right here, because that's a good approximate there. Okay, number 2 is 3 times 13. Square root of 3 times square root of 13. Same exact thing. They share the same index number, which is it is square root 2. So we do say like 3 times 13. Square root of 3 times 13 will become 39. See if you can simplify them. This cannot be simplified. Simply we can just write down that number. Plug that number in the calculator. It'll give you approximation of 6.245. So that means if you want a complete square root of some numbers, the closest complete square root is 36. 36 square root is 6, and we just have to find out like, okay, what is remain? It's almost 4, but not completely 4. And that's how, like, it will be a big discussion. If we are interested, we will talk about how to find number square root without using calculator or approximation. But since we have calculator, we will plug in, and the reason we are doing this thing to teach you and to learn how to use these methods to find the values from the calculators also, and as well as doing it by hand and by memory. So moving on to the number 3, that will be you guys. So we'll do number 4. Number 4 is cube root of 3 times cube root of 9. We have to write down the index for this cube root, because if you don't, that will become as a that will become as a square root, actually. Excuse me. So cube root of what? They share the same degree, and we can multiply. 3 times 9 cube root. 3 times 9 is 27 cube root. And we can further simplify. That will be, so we can do 3 times 3 is 9. 9 times 3 is 27. So it will be 3 to the power 3 square is cube root of 3. I'm sorry, cube root. Cube is 3. So this will cancel out. Will become, the answer will be 3 only. Okay, next example number 5 is negative square root of negative 3 times square root of negative 6. So this individually these don't have any value, any real value, but since we have a multiplication step involved, we can solve it, because negative times negative will become positive, and they share the same index number. So it will be negative 3 times negative 6. Negative 6. So that will become negative times negative is a plus. The positive will be 3 times 6 is 18, square root of 18. Let's see if we can further simplify that. 18 is consist of 9 times 2. And we can write down 9 as a 3 squared. Let's do that right here. 3 squared, square root of 3 squared times 2. So we can pull this number out because 3 squared, if you take it out of the square root, will become 3. And the inside will become only square root of 2. So 3 times square root of 2 will be our final answer for that. So let's verify that. So it will be 18. If you plug in 18 in the calculator, it will give you this answer. If you want to further simplify it, you can just write down the approximation. It will be 4.24. Okay. Moving on to the division of the square roots or the roots. Square root of 15 divided by square root of 3. Question number 6 is square root of 15 divided by square root of 3. So we can use the law that we just talked about, the rule. We can put them under the same index number, that one, or just do 15 divided by 3 square root of 2, or square root the root degree of 2. So 15 divided by 3 will be 5, the square root of 5, and we cannot simplify that, but we can just approximate that number in the calculator. It will give us 2.236. So that's simply that is how that works. We share the same index number. We will put them under the same index number and do the arithmetic operation on there. So 15 divided by 3 is 5. Either way, 15 over 3 or 15 divided by 3 is 5. Square root of 5 will give you 2.236. Okay, moving on to our last question. I'll leave you guys with this one. Number 7 and number 3. Try to solve these two. And now let's try to solve number 8. Square root of 13 divided by square root of 6. Number 7 is, no, not 7. The 7 is you guys. Number 8 is, let's clear that. Don't want to confuse you guys. Okay, so number 8 is square root of 13 divided by square root of 6. Okay, now we said we can write them down as because they share the same index number, so 13 divided by 6, and that can be written down as that number, 13 divided by 6. They share the same root, so that is not simply divisible, but it's not complete numbers. The answer will be 2.16 repeated. So if we can just put it like that, that will be your final answer. Or if you want to simplify it, you just plug this number in the calculator. It'll give you approximation of 1.472. So that means it's not a complete number, so it's an irrational number. So because it cannot be written down as a fraction here, because that number keep going on, so we did a approximation in this case. Okay, so it was not that bad. It wasn't even bad. So hopefully this will make sense. It requires some practice. Please go back and read and re-practice these questions. If you have any question, please submit a question in the comment section. Okay, before we finish this square root, we'll talk about two word example with words, and we'll finish our a square root sessions. So there's a question. It said like, okay, Derek Brown has a floor garden which is shaped as a square. The total area is 144 meters square. what is the measurement of each side. So this side is like it's asked like find either side, two sides, because it's a square, so all the sides should be equal. The length is equal to the width, so area is equal to the length time width. In this case, since it's square, the length is equal to the width, so it will be length time length will become length square. So if you find one, that you'll find the other one. So length squared is equal to 144 meter square. So what we can do, length square, we can put them under a square root, and we can also do the can also put 144 meters squared under the square root, both side. So this will cancel out with that. L is equal to 144. We can simplify that, will be 12 meter times 12 meter, because meter times meter will be meter squared. And now we can also write down this one, so it'll be 12 meter. Can do that square, because 12 times 12 is a 12 square, meter times meter is a meter square. This will cancel out. Our length will be equal to our width, and that will be equal to 12 meter. So this is 12 meter, this is 12 meter, and this is 12 meter, and all these sides are 12 meter, so because it's a square root. Okay, last example here. The work table at my work is shaped as square. The area of the table is 625 square feet. What is the dimension of the table? So it's asked to find this area and this area. I mean this length and that length. So the area is given 625 feet. We gotta find this length and that measurement here too. So this is actually a table at work. So how we do that? Same exact thing. This is square. For square, we say like A is equal to L times W. So since these are equal, this time we say like, okay, A is equal to W square, width square, and that is area is 625 foot square, and that will become W. We will put them both under the square root of 625 foot squared. Put them under the square root, and that will give you a good number of 25. So width, which is equal to length, and that will give me 25 feet. So this X is 25 foot, and this is 25 feet also. Okay, hopefully this wasn't that bad. X is equal to 25 feet. And if I call this Y, and Y is equal to 25 feet also. Let's call this Y. Okay, so let's try to wrap this thing up, and we will be finishing up this thing. We talked today about a square root. We discussed some example. We talked about some properties. Hopefully it wasn't that bad. We'll meet back again with a cube root in this course. Please go back and read, watch those videos before the arithmetic operation, and with the power and exponents. That will help you a lot. We'll be moving on. We'll taking step forward to pre-algebra, so getting ready to shift gears. Until then, guys, take care and see you.